Laplace Transforms Part 3, calculating with the table. This is a little bit like using the differential table when you're differentiating. On the left here you can see we've got the function of time, or t, and on the right the Laplace transformation has been applied to get our function of s. We could also write that this is the Laplace transform of the function of time. To give a demonstration, if we have the function of t, if that equals t cubed, we can look at this table here and say, well, we've got t to the n, which becomes n factorial over s to the n plus 1. So I'm going to write a little note that says n equals 3. We'll then have the function of s equals n factorial, or 3 factorial over s to the n, or 3 plus 1. 3 factorial equals 6 over s, well, 3 plus 1 is 4. So our function of s is 6 over s to the 4. Let's try it with a different one. Let's try it with f of t equals cos of 7t. So I'm looking at this one here, which means the Laplace transform applied will give us this function of s. So I'll write a little note to the side that a equals 7, because we've got cos at, in this case 7. We'll then have the function of s equals s over s squared plus 7 squared, which equals s over s squared plus 49. Quite straightforward to begin with, so here's 5 questions for you to try before we move on to the next part. The fully written out answers are on my website, letsdomaths.co.uk, and also there's a link in the description below. Let's step it up a notch. If you have the Laplace transformation of a constant or coefficient of a function of time, that's going to be equal to the constant of the Laplace transform of the function of time. This means that this constant here, like with integration, the numerical factor can be pulled out to the outside and multiplied by that entire function. Here's what I mean with 2 examples. If we have the Laplace transform of 5t to the 7, well, we can see in the table that we've got t to the n, which we're going to use this one. And this states that actually, because we've got t to the 7 here, we can pull this coefficient 5, that's being multiplied by t to the 7, out. So we'll have 5 lots of the Laplace transformation of t to the 7. We can use the Laplace transformation table for this part. So t to the 7 becomes 7 factorial over s to the n plus 1, or s7 plus 1. And this has all been multiplied by 5. This is then 5 lots of 5040 over s to the 8. And our final answer, f of s equals 25,200 over s to the 8. Our second example, the Laplace transform of 9 sine 2t. We can see we're using sine at, which becomes this. We've got this coefficient at the front, so we can factor that out to give us 9 lots of the Laplace transform of sine 2t. Using the table, we'll then have 9 lots of, well, a is 2, so 9 multiplied by 2 over s squared plus 2 squared, giving us our function of s equaling 18 over s squared plus 4. Taking this one step further for this video, if we have the Laplace transform of a constant multiplied the function of time plus a constant multiplied a function of time, we can break that down into 2 Laplace transformations consisting of this one and this one. And we can take the coefficient out from each of these functions. So this will become 1 Laplace transformation with the coefficient taken out, which then becomes the coefficient multiplied by the Laplace transform of a function of time. And then we're adding the Laplace transform of this coefficient of g of t, which becomes the coefficient multiplied by the Laplace transformation of g of t. If it sounds confusing, don't worry, I'm going to show you what this means. If we have the Laplace transform of 8t to the 5 plus 15 sine 3t, we can first break it down into this and this. We have the Laplace transform of 8t to the 5 plus the Laplace transform of 15 sine 3t. Looking at the green part, we can take our numerical factor of 8 to give us 8 lots of the Laplace transformation of t to the 5. Then we're adding the orange part, and we can take out a numerical factor of 15, giving us 15 lots of the Laplace transformation of sine 3t. Use the table to find the Laplace transforms of each of these, and you'll get a final answer of 960 over s to the 6 plus 45 over s squared plus 9. And that's this expression converted from the t domain into the s domain. Last 4 questions for you to try. Pause the video and resume when you're ready for the answers. Well done if you've got all 4 correct. Well done if you've got any correct, to be fair. Remember, the fully written out answers are on the website and in the description below. The next video applies an important aspect of Laplace transforms, which is the step function. So check that out next. Thanks for watching, stay safe and healthy, and I'll see you in the next video.